Now we talk about shells and subshells in chemistry. This is a shell, and this is a subshell. So a subshell is a shell inside another shell. A shell, subshell, the small ones are subshells. A shell inside another shell, or part of another shell. In chemistry, shells are the spaces or the places where electrons move. So these are the shells where electrons move. This is the nucleus of the atom, and these are the shells. Here we have protons and neutrons. Outside we have electrons. Electrons move in shells and subshells, and we will talk about that in more detail. The atomic number for magnesium Mg, is 12. That means that it has 12 protons and 12 electrons. So what we are interested in is the 12 electrons. Where are they? Where do the 12 electrons go? So this is the nucleus. In the nucleus go protons and neutrons. Electrons will be in shells and subshells around the nucleus. Let's color them to know what they are. This is shell number 1. That's when n number 1, we call it n equals number 1. And that's shell number 2, and that's when n equals number 2. And that's shell 3, n equals 3. Shell 4, we call it number 4, n 4. And that's shell 5, number 5, and that's when n equals number 5. The reason I say n, because we will use n to know how many electrons in each one. So how many electrons in each shell? They don't take the same number of electrons in each shell. Shell number 1 takes only 2 electrons. Shell number 2 takes only 8 electrons. Shell number 3 takes 18 electrons. Shell number 4 takes 32 electrons. Shell number 5 takes 50 electrons. We said shell number 1, n equals number 1. Shell 2, we call it n equals 2. And shell 3, n 3. Shell 4, n equals 4. Shell 5, n equals 5. The number of electrons in each shell goes as follows. Follows this equation or formula. 2 n squared. What does that mean? Means 2 multiplied by this number or this number or this number squared. N in itself. So we do this one in itself first and we see how many electrons. So for number 1 here, it will be 2 multiplied by 1 squared. 1 squared equals 1, means 1 by 1 equals 1. So 2 multiplied by 1 equals 2. That's why we said shell number 1 takes 2 electrons. 2 electrons. Shell number 2, this one, that will be, we said the equation is 2n squared. So 2 multiplied by 2 by 2, or multiplied by 2. This one, 2 multiplied by 2 equal 4. So 2 multiplied by 4 equal 8. The second shell takes 8 electrons. Let's see shell number 5. That one. So it will be 2 multiplied by 5 squared. 5 squared equal 25. So 2 multiplied by 25 equal 50. So this one takes 50 electrons. So this takes 2, 8. If we do the same thing with all of them, we'll realize that this one takes 18. This one takes 32. So 2, 8, 18, 32, 50. That way, shell number 1 takes 2 electrons. Shell number 2 takes 8 electrons. Shell number 3 takes 18 electrons. Shell number 4 takes 32 electrons. Shell number 5 takes 50 electrons. The shells have subshells inside them. The electrons are divided in the subshells. This is the nucleus, the first one. This one is the nucleus. This is where the protons and the neutrons. This is shell number 1, 2, 3, 4, 5. These are the 5 shells that we have. Red is number 1, brown number 2, green 3, blue 4, and purple is 5. These are my colors. I put the colors. They're not exactly like that. I put the colors. Just so we know. Shell number 1 has only one shell, doesn't have any subshells. Shell number 2 has 2 shells. Shell number 3 has 3 shells. Shell number 4 has 4 shells. 4 subshells. The order of subshells is S, P, D, and F. S, P, D, F. This is the order of the subshells. Shell number 1 has only 2 electrons and it does not have any subshells, so we call it S. Shell number 2 has 2 shells. So the first subshell we call it S, and the second subshell we call it P. The third subshell has the third shell has 3 subshells, so we will call them S, P, and D. So the first one we'll call it S, The second one will be, we'll call it B. And the third subshell will be called D. So for the green one, we have S, P, D. That's number 3. S, P, and D. For the blue one, which is shell number 4, we have 4 subshells. So we'll call them S, P, D, and F. Any subshell S takes 2 electrons. Any subshell P takes 6 electrons. Any subshell D takes 10 electrons. Any subshell F takes 14 electrons. Any subshell S takes 2. Any subshell P takes 6. Any subshell D takes 10. Any subshell F takes 14. What does that mean? Shell number 1 usually gets 2. Shell number 2 gets 8. Shell number 3, 18, gets 18. Shell number 4 gets 32. That's number 4. So for magnesium is 12. So out of the 12 for magnesium, Mg, there will be 2 for the first shell, 8 for the second shell. 2 plus 8, that's 10. So 2 plus 8, that's 10. How many is left of the 12? Only 2. So only 2 will be in the third shell. So it will be like 2 electrons here. It will be 8 electrons here. And then will be 2 electrons here. Those electrons will not be on the same level. There will be subshells. Inside the shells, there are subshells. S doesn't have any subshells, and we call it S. The second one has 2 subshells, and we call them S and P. Two S and 2P. The third shell has 3 subshells, S, P, and D. Call it 3S, 3P, and 3D. The fourth one has 4 subshells. We call them S, P, D, and F. 4S, 4P, 4D, and 4F. The first one is only S, one S. The second one S and P. The third one S, P, D. The third one S, P, D, F. Each one of the subshells takes a number of electrons. The order of the subshells will be 1s, that's for the first one. The second one has 2, so it will be 2s and 2p. The third one has 3, so it will be 3s, 3p, and 3d. The fourth one has 4, so it will be 4s, 4p, 4d, and 4f. Every S subshell takes 2 electrons. Every P subshell takes 6 electrons. Every D subshell takes 10 electrons. Every F subshell takes 14 electrons. If we look at magnesium, which has 12 electrons, this is the atomic number, and it shows the number of electrons. Of course, it will have 12 protons here in the nucleus. This is the nucleus. And it will have 12 protons. Now we are talking about the electrons. 1s will take 2 electrons out of 12, so we have 10 left. 2s will take 2 electrons, so 2 plus 2, that's 4, so we had 8 left. 2p will take 6 electrons, two plus 2 plus 6, that's 10 out of 12, so we have 2 more. So the last 2 will go in 3s. So for magnesium, it will be 2 for 1s, 2 and 2s, 6 and 2p, and 2 and 3s. When you look at the periodic table, you'll find the magnesium here in the S block. All of the elements here, all of them end up having their electrons in one of the S subshells. It can be 1s or 2s or 3s or 5s. That's 1s, 2s, 3s, 4s, 5s, 6s, 7s. So that number here that tells you, the place tells you that the name of the subshell. So all of these elements here in this corner of the table are the elements whose last electron, the last electron is in the S subshell. The elements here in the middle, the green block, are in the D subshell. Let's take an example. Now let's look at titanium. Titanium has an atomic number 22. The atomic number for titanium is 22. The atomic number for titanium is 22. The distribution of the 22 electrons will be 1s. We'll take 2 electrons. 2s. We'll take 2 electrons. 2p. We'll take 6 electrons. 1, 2, 3, 4, 5, 6. 3s will take 2 electrons. 3p will take 6 electrons, and 3d will take whatever is left. Let's count how many we have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So how many are left? 4. So 3D will take the remaining 4 because it's 22. 2 will go here, 2 here, 6 here, 2 here, and the 6 here, and the remaining 4 will be here. The remaining 4 will be on 3D here, somewhere in here. If you look for titanium on the periodic table, you will find it's in the D block. This is the D block in the middle of the table. All elements in the D block have the last electrons in the D subshell. It can be any one of the D subshells. It can be 3D, 4D, 5D, 6, 7. Now try your own with sodium. It has 11 electrons. Okay, did you follow the steps?